Hey there, I'm coming at you with another experiment. This one was from the beginning of April, and it talked about how would you investigate how heat transfers. So I'm going to do experiment one. So the first one asks you, suppose you have two glasses of water. One contains a small amount of ice and the other contains a large amount. After the ice melts, will they be at the same temperature? Why or why not? So this was an open-ended experiment and getting you to sort of think outside the box, but just with not too many materials. So we have two glasses here. Ooh, shiny glasses. Some ice. Small amount of ice. Large amount of ice. Well, that's a bit too much ice. So the idea is you put some water in there. So boom. One has a large amount of ice and the other has a small amount. And you let them melt. Time passes, time passes. You see nothing. You see nothing. You still see nothing. So after they melt, now you see things. How would you measure their temperature? Will they be at the same? Now, there's a lot of ways to do this. You didn't have to have a lot of technical equipment. For example, it says the general description of the experiment. You fill a couple of cups with ice, you let them melt. How will the masses of the materials be measured? Well, one how is one heavier than the other? I know you didn't have any scales at home, or many of you didn't. So it was more just an estimate. How much snow will be in each, or ice will be in each glass of water? That was just a measurement of, well, 6 cubes of ice, 3 cubes of ice, 1 cup of snow, 2 cups of snow. What data will you record? Every so often, you walk up to the glass and go, which one feels colder? Then after completing the experiment, answer the original question. Are they at the same temperature? Why or why not? So you just at the end feel them and say which one's colder and why is that? Now it does ask you about independent variables, dependent variables, and controls. Remember that control is something that remains the same throughout the course of the experiment. So the glass doesn't change. Dependent variable and independent variable. Independent variable doesn't change. So in this case, we try to have the same amount of water. But the dependent variable does, how much ice is in there, and then whether or not it melts. Dependent variable is dependent, can change based on the independent variable. So I know we didn't go into that too much. It was a bit of a stretch, which is why I included the vocabulary sheet. But that's all for heat experiment 1. Hey, we're back with heat experiment 2 from the beginning of April. And the last one was looking at 2 glasses of water, each filled with different amounts of ice. This one simply says, suppose you have a small amount of a substance and a large amount. When heat is applied to each, which will reach a higher temperature? Why? Well, we could go back to glasses of water. They're not equal glasses. Unequal glasses is best. Large amount, small amount. And so, how will the masses of substances be measured? Which one feels heavier? How much substances will be in each glass? Well, half full glass, fractional full glass. Again, I know that this was something that you didn't have exact measurements for, but thinking outside the box, we can just use estimates. We're just managing to get the concept, not necessarily being precise. What data will you record? Well, if it's asking you to heat each up, well, how much time does it take to get warm? Now you gotta be careful, because if you heat it up, of course, there's safety issues and such. So just be cautious on that. So again, your control is your glasses. Your independent variable is your the independent variable, the variable that's not dependent on anything else, is your water. Your dependent variable is the heat of the water. How much water there is can change. Now there's a couple of other ones that it could be, but the idea is just thinking about it. Again, I know that one was a bit more of a stretch. It was just getting you to think. But our ultimate goal is, suppose you have a small amount of each substance and a large amount. When heat is applied to each, which will reach a higher temperature? The answer is going to be the small one at first, because this deals with the term of heat capacity. A glass of water can take more heat before it starts boiling. That's why a pot of water takes a lot longer to boil than just a little bit. So that's all for experiment number 2. And we're back with experiment number 3 for the heat experiments. So already you've done the experiment with different amounts of snow and ice, water. Already you've done experiments with different amounts of the same substance, showing you heat capacity. Now we come to different materials at all. So the goal is to have about the same amount. So what do you suppose is your control? Well, the glass. Your independent variable is the amount of each, and your dependent variable is how much heat they get. I mean, there could be a couple of other ways. But again, that question is not quite as important as looking at the concept behind this. So which of the two substances, when you want to increase their temperatures by a certain amount, will they require the same amount of heat? Basically, do you need a bigger fire to heat one up to the same level as the other one? Why or why not? So you experiment, put 2 glasses, fill each with the same amount of material, but again, different materials. How will the masses of the materials be measured? Well, figure out just how heavy they are just by guiding it. How much of substance 1 will be in one glass? About half full. How much substance will be in the other glass? About half full. What data will you record? That's, again, the time it takes to heat up to a certain temperature. Now, you may want to figure out what that kind of temperature is. It could be how much it feels on a stove. It could be putting it in an oven. You know, be safe out there, but you have to kind of design the experiment yourself. You want to increase their temperatures by a certain amount. Will they require the same amount of heat? So the goal with this one is simply to find out that no, different materials do require different amounts of heat because they're made of different things. You know, it's a lot easier to heat up a piece of metal than it is to heat up a cake. You know, you already know this. You've experienced it in your life in some form or another. This is just a small, simple way to kind of illustrate that. So that covers all 3 experiments. I hope it helps in some small degree, and you can move forward.